And who'd be better to introduce us to this topic than Professor Wolfgang Prinz. He is the vice chair of Fraunhofer FIT. He's a professor at the University of Aachen and has 30 years of experience in research and development. And today he's going to give us an intro into blockchain technology, but also points how we can apply it. I'm super excited. I hope you are too. Please help me welcome to the stage with a big round of applause, Professor Wolfgang Prinz. Thank you for joining us.
Thank you. Yeah, thank you very much for the kind applause. You don't know yet what you should expect. He mentioned already 30 years ago, I started research, and looking back, actually, my first visit of this particular fair was when it was not yet called CEBIT. It was still the Hannover Fair, and I was a student, and I did a lot of programming. And in this case, it was for RWE, now Innogy. And what we did at this time was just some kind of simulations. And it was very nice because I could earn some money. Unfortunately, I did not invest this money into any cryptocurrency. I jumped on the whole bandwagon much too late, but we jumped very early on it from a research point of view because we were very much interested really in understanding how this new technology can change organizations, applications, infrastructure, and all the rest. So we started almost 3 years ago, we started our research lab at Fraunhofer, where nowadays we do a lot of different application developments, proof of concepts, also education in this area. And here you see some of the application areas. So it's for smart grids, how to exchange energy, distributed media production and copyrights, blockchain and mobility, in particular in the context of autonomous and hybrid cars, Internet of Things, logistics, the big industrial data space that has been founded more or less by Fraunhofer. And if you really want to see some applications, I think you will see a lot here at the fair. You can also go to our booth at Hall 27, E78, and there you will see how blockchain really can be used for educational purposes. Now, enough of advertisement for our institute. Let's have a look at the reasons why we believe, and some other people also believe, actually, that blockchain really can make a change, and why we are nowadays talking about it. I mean, the technology is out there for almost 10 years now. But nowadays we are talking about it, and maybe it's just the right time or the technology is mature enough. But what you see here is just an idea, how could the past of the World Wide Web be classified? At the beginning what we did web page programming. We edited HTML pages, and what we distributed was information. The next wave was really that we put some basic services below that and beneath that, and then we are talking about the Internet of Services. That's how you book your flights. Now we bring everything on small devices. We put it on the Internet of Things, and I just heard that you recently had Google Home and Amazon here with all the devices, which is a nice example. And what's the next? I mean, what is the next big wave that we see within the Internet, and what can make a change? And we may find an answer to that if we look at some properties that the Internet currently has. And if you like, for example, that presentation, and you ask me afterwards, well, could you please give me your slides? What can I do in the Internet? I can copy them, or I can share them with you. I send you a link, or I send you a copy. But I can't just, with normal Internet means, give you the right to show these particular slides next time. If you want to do that, what we need is a lawyer, we need a notary, or we need someone else who is just organizing this transfer of the right and the transfer of the value from me to you. So we need this kind of intermediaries, and this is what we currently see with all the different platforms that we have in the Internet. It's, yeah, and what I show here is the cityscape of Frankfurt. Yeah, it's banks, it's something like TÜV, it's PayPal, it's all the big platforms that provide the security of transactions based on their organizational methods, on their organizational concepts. Now, if I transfer 10 euros to you, I go to the Sparkasse Köln-Bonn, that's where I come from, Cologne in particular, and then I hope, and not hope, I believe that they have the organizational methods right at hand, that there is no super user who can fool around with my transaction, because they just do it from an organizational perspective. But it's not really based just on the algorithms, and we still need the bank who is ensuring that for us. And now is the question, can we do this in a different way? And that was the original idea behind the original Bitcoin paper from Satoshi Nakamoto. And just briefly, I'm not going very deep into the algorithms, but just to identify some particular aspects of blockchain technology. The first thing is that we take away the central institution, we replace it with a network. Yeah? So we just we put a network in the middle, and this network can be public worldwide. It may even be just closed and permissioned. We come to that later on. Next thing is that we have to distribute the data. It's not a single point of reference where we have the data. We replicate it to all the different nodes. And you see, it does not really look like a database. What you see there is the blue symbol. It looks a little bit different, so we have a different data structure, which is the blockchain. And this particular data structure has been designed or invented, call it what you like, really to support the irreversibility as well as the comprehensibility of the data. Yeah? So the data structure also is a very important aspect. The next thing is that we distribute transactions in the network. Now, we are not giving them just to our bank, we just send them into the network. And you see here a lot of different transactions. And what would happen if these transactions would just be added by the different nodes to our ledger, to our blockchain? You see that some nodes know about my transaction of 10 things from A to B. Some don't know about it. There are other nodes that know about a transaction from D to E, about 20 something. But not everybody knows everything at the moment, and it's not consistent yet. And if everybody would just add things to our ledger, we would result in a completely inconsistent, incomplete, not reliable data structure at the end. Everybody knows something different. Therefore, we need to determine who should do it. And imagine that we now build a blockchain here. How can we determine who should do it? I could just ask the oldest, the youngest. I could just ask you a question. I find a random number, and the person who's answering or who's coming closest to it is the one who's doing it. And with that, we are coming already quite close to what is happening, at least in Bitcoin, Ethereum, and in other blockchains. What the people have to solve is some kind of a cryptographic puzzle. They have to find a magic number that, in combination with the data that they want to add to the blockchain, satisfies a certain condition. And that's what they call the proof of work, because it's something that you can't really do on an algorithmic basis. You have to do a lot of tests, you have to try, and it's easy to paralyze, and that's the reason why we have these big, big data centers and big, big computing centers where we have a lot of computers that all try to solve this puzzle. Now, the lucky node who finds or who solves this particular crypto puzzle is the one who creates the new block. He adds it to the blockchain, he provides the solution, and then he distributes it to all the other nodes, and then they just check whether he did it right, which can be done very quickly. Yeah, so that's also the reason why they call it an asymmetric function. It takes a lot of time to find the solution, but in order to check the solution, that can be done right away. So, and then he distributes it to all the other nodes, they check it, and then they say, okay, he did it right, he's the lucky guy, he will get some incentives for that, and we accept that block, and then the whole puzzle starts again. We get more transactions, we do it again and again and again, and therefore the blockchain is extended by new blocks. And the blocks are connected to each other also by some cryptographic means, which ensures that it's all consistent and that nobody can tamper without it, and that it becomes irreversible. So that's the basic principle, which means that within this network, we don't have a single point of reference. We have now a complete distributed network, a decentralized network, and it's quite safe against any tampering, against any change of data, because it will be immediately detected that people tampered around with that. So the other people in the network will detect this immediately. You can do it. You can download your own blockchain server, your blockchain miner, and then you can start tampering around, but you will not be successful with that, I can tell you. So until then, you may say, okay, what's behind it? It's just something like a decentralized database. Heard about it's quite slow. What's the magic? People talk about automation. And that's now the point when what some people say blockchain 2.0 or Ethereum or other kind of blockchain implementations come into the game, and then we talk about smart contracts or chain code, as other people say. What we do now is that we make out of this very static, boring thing where we store data in, we now make it live. We bring programs or agents or smart contracts into our transactions, which means that we do not just submit a transaction, A transfers to B 10 something, we connect that to a condition. Yeah? So, for example, only if Germany wins on Sunday 2-0, I pay you €5. And we establish that in a smart contract. And since you don't trust me, we could do this right away without a blockchain, but maybe you don't trust me, and after this talk, I'm just off and away, and you go back to your home. We put this in the smart contract that will be executed as soon as the result is done, is ready, and then you get your €5, and I can't tamper with that. I can't do anything against it because we put it in the blockchain, and the smart contract is as irresistible or as tamper-proof as the transaction itself. And therefore, we get now some kind of an ecosystem, a worldwide computer where we store data or transactions, and where we also store some kind of agents, smart contracts, chain code that executes on our behalf, and that now became a new ecosystem where we can just jump upon. You can write your own smart contracts, submit them to the blockchain, and soon you have built your own kind of small business for betting services, for other things on that. And if we think now about industry, IoT, sensors that want to be paid for their service, we can all do that now with this kind of smart contracts, obviously also with other things, but here we can do it in a very nice and special way. We also see that there are some problems, it can become a nightmare. We all talk about agile software development. Okay, we develop software on demand together with our users. On the other hand, this guy in front just said, oh, you can't change them anymore. Yeah? So it's a little bit of a contradictory thing, but this also can be solved, and there are also solutions for that, but you have to take care that what you send to the blockchain remains there. But in the meantime, there are also business solutions around that can overcome this particular problem. So, to sum up, for this first stage of the technology, what makes blockchain technology attractive? We have consensus building in a network. It's not the bank, it's not the notary, it's not the something that is dealing with our ledger, that is managing the ledger, it's the network that is doing that. We now can transfer value and rights. Now we can register in the blockchain that this particular presentation is no longer my property, but I hand it over to you, and you can show it. We can even add a smart contract that whenever you show it, I get 1 Bitcoin would be cool, yeah? Let's say just some 10 cents or so. And we also can automate the whole thing using these kind of smart contracts. And that's the reason why we now say we are now moving onwards really to an internet of value, internet of trust, that is enabled by the blockchain technology. So I tried to convince you now that this is quite a new technology, and then you see something like that. It's in German, but it says, well, it just uses too much energy. It will never become any currency. And you see it even here, some nice figures. Bitcoin is just in the middle, which means that the energy consumption, for example, by Bitcoin, is a little bit less than Chile, but even more than the Czech Republic. So that's quite a lot. But that's just for the case of Bitcoin and other cryptocurrency blockchains. And I would like to draw a red line here. Currently in Berlin, a lot of people draw red lines, but this is now a red line in this technology. You see, we talk about distributed ledgers. Axel mentioned that already in his introduction. It's a register where we register things, and we have technologies for that. We have blockchain as a particular technology. We have smart contracts that can be added to the blockchain, and then we have applications on that. And we have applications like Bitcoin, Ethereum. We have ICOs, these initial coin offerings, where startups make a lot of money out of that, which are applications of the blockchain. And it doesn't mean that what we hear about that actually has a big influence or just is the whole technology itself. It's not the disadvantage of the technology that for the Bitcoin network, we have this energy. It's just this particular way of using it. And if we look now at the IT landscape of blockchain, we can say blockchain unchanged. We may see why in the future we can expect a lot of more solutions beyond Bitcoin, Ethereum, and what we know today. And the reason for that is that actually blockchain, if you talk to old IT people, they will tell you, look, this is just a very cool combination of technology that we knew about already before. It's distributed systems and networks, peer-to-peer networks, and things like that. It's cryptography, public and private key, hashing, things like that. It's software engineering, smart contracts. We were talking about agent technology years ago. Yeah? And now we talk about this in the context of smart contracts. And it's about data structures. Blockchain is a data structure in itself. We talk about consensus methods, like proof of work. Talk to people from distributed systems, and they will tell you, well, that's Byzantine fault tolerance that we have to deal with when we talk about big computing networks. And if we look at this, we see that based on the fact that blockchain is a nice combination of different technologies, we see that new things pop up. And that makes it very interesting. If we look at the blockchain data structures, for example, this is a typical example for the blockchain, the Merkle tree, and how we hash things together and we connect it. And this looks like blocks that are connected by links. Good. Other people come up. Hyperledger Fabric, where they use other ways to store data in a complete different way, in a very clever way, because they overcome this point that they say, well, in this kind of blockchain, everything is transparent, everybody sees everything, we need channels, we need other ways of communicating, we need other ways of smart contracts, and they use another way to store and represent the data, and also to do the consensus building. That's Corda R3. That's a distributed ledger technology. It also looks different. In this particular data structure, not everybody knows everything. You only share things with people you trust, with people you cooperate with, but not with everybody. That's Tangle from IOTA, another cool startup that comes up and that says, well, why do we need blocks? Why do we have this sequence of blocks? In IT and in mathematics, we know graphs. We have directed acyclic graphs. And maybe we just say each of these transactions is just a single entry in this graph, and we use a complete different way to organize that. Or we use another thing like hash graph. And you see another kind of data structure that says, well, we use the principle of gossips. If I have a gossip, and I tell you this gossip often enough, it means that in the end, this gossip is moving around. Let me see, I need to fix that. This gossip is moving around, and if enough people believe it, we trust it somehow. And that's what you see in this hash graph. So you see, from the data structure point of view, currently we see a big development of new data structures, how we represent transactions in a blockchain. The same is true for the consensus algorithms. Bitcoin, Ethereum, still for the moment, they use proof of work for the reason that they have very big public networks. And here it's a very good and proven way to find consensus. Here you see a diagram that shows, well, you also could just determine a single node for a blockchain. I could just point you out and say, well, it's you who is always adding transactions to the blockchain. It's the easiest way. He can do it very fast. We don't need proof of work. We don't need much energy. We can solve that. But we need to trust him. So you see, the difference between the left-hand side, proof of work, and the right-hand side is also the level of trust. If we are working closely together, we can use that technology based on the trust that we have, and then we can use different ways of consensus. And you see, in between, we have different levels, like lotteries or proof of stake or things like that. So we really can use different mechanisms to do that, and we get a better performance on the one hand side, but on the other hand side, we wouldn't just run a complete crypto network for a new cryptocurrency by just trusting him. Maybe you would, I probably wouldn't trust him that he's doing everything right, therefore we use it to the left. Which means that we have a wide spectrum really on different technologies that you can use. Whether you want to have a blockchain that is running logic-oriented, so it does smart contracts, you really can establish new kind of decentralized organizations on top. You do it in the open way. You go, for example, for Ethereum, you do it more in the consortia-oriented way. You do it with something like Hyperledger Fabric. Or you say, well, I just want to be completely open, just transaction-oriented. You go with Bitcoin or with something like BigChainDB in the permissioned way. Yeah? So it's can really differentiate. Should it be completely open, everybody's allowed to do, or just do I go with a more localized, a more trustful environment, a consortia in which I do it, which we then also call a private and permissioned blockchain. So you have to ask to participate. Some people who are the real blockchain enthusiasts, they say everything on the right-hand side, that's not a blockchain. Yeah? Blockchain is transparent, open, everybody can join, and now these people come around and say, well, let's do it more closed. Why not? Why shouldn't we do that? If it solves our problem, yeah, I'm completely open to any of these solutions. And now you may ask, what's the best thing for me? And the obvious solution, it depends. It really depends on the application of the use case, the identification of the transaction data, the transparency of the consortia, the business process privacy that you have, the scalability and the automation. And if we look now at different application areas, we may find in the end somehow a process to identify a good application area for blockchain. Because what we see at the moment is obviously also is that we see a lot of hype, and some people criticize that. On the other hand, not everything is just good for a blockchain. Yeah? I mean, you will find applications that are much better and much easier be solved by just using a relational database or traditional IT systems. Here are some application areas where a lot of people believe that that could really be helpful. For example, in the Internet of Things. I mentioned that already. You have sensors, and these sensors need to provide data. You have other kind of actuators. They want to buy the data. How do you do that? Well, you can fix that in a smart contract. And you do the immediate cash flow also within the blockchain. In a smart grid, you own a photovoltaic roof. I don't own a Tesla or any other German e-mobility car. But if I would own it, I could ask you, please just sell me your electricity and I pay for that. And instead, my car would just negotiate that with your roof. And then we get into complete new models how energy, which is already being produced decentralized, can then also be managed and paid for in a decentralized way, not just by my energy provider. Proof of origin. Do you ever check, if you work, for example, in an HR department, that the application that you get from a student, let's say from my university, really is original? What you normally get is a PDF. And I can tell you, all the students from our university, they know how to fool around with PDFs. They don't do it, obviously, but they could do. So you really would need to ask the university back. If we put all our certificates in a blockchain, you can easily check that. That's what we actually show at our exhibition. Or in a supply chain. You really have a very flexible way of moving things around. And maybe even a container who becomes its own identity, asks a lorry to take him from here to Hamburg, then he's asking a ship, can you take me to America? And then even there is a smart contract where you have to pay the additional toll, yeah, originated by Trump. So we may also insert a smart contract there, but that can really be somehow managed and also completely by autonomous things that move around, and we can turn the whole supply chain upside down with that. Now, let's go through that in a more detailed example. And let's say example, blockchain and production. And that may also be helpful for you to identify a process. If you think about the fact, well, I have some ideas, could that be a good, useful use case for a blockchain? So what you see here, in German, are some aspects of a blockchain. So it's data and process integrity, decentralized network, we can transfer value and write, and we have a lot of automation potential. If we take this up, and we think about some of the aspects there, just the fact that we have some kind of data and process integrity, we can store certificates of users and machine. And in the future, the machine will ask the user, hold on, are you educated to use me? Can you control me? An elevator may ask the service personnel, have you really been approved by the TÜV to do that, what you're trying to do with me? We can quality control in the supply chain, really tracking of the way things have been moving around. And you will see a lot of use cases, I think, here at the fair from different exhibitors. We can transfer values and rights, copyright, ownership, who owns something, orders and transactions, or even machines who have machine-to-machine communication. One machine orders something at the other machine. The added value of the blockchain is actually here that it's registered in the blockchain, that you can have also the payment within the blockchain. So we get some already advantages just from the single properties that the blockchain offers. But if you combine it And add the network approach to that, we can say, well, it's no longer a platform that comes up to support that. It now can be handled in a decentralized network, and it can be handled within our organizational network, within our supply chain, within our business network. And we can then just organize that in a complete different way, no longer relying on a central platform that is doing that for us in the end. So we get to flexible supply chain networks or even share economy. You know? Now I can share things with people I don't even trust because based on the blockchain properties, I'm sure they will pay in the end. It's not Airbnb who guarantees that or Amazon. It's blockchain applied technology that is doing that. Okay, so these are some properties, and now you may ask, okay, I have a use case. Does this use case, is that suitable for a blockchain? And people at ATH in Zurich, they published a nice paper, and they have this decision tree. Yeah? And you can ask yourself, do you need to store a state? Are there multiple writers and things like that? And in the end, you come up, and it tells you, well, use this kind of blockchain. That's quite nice. One thing with it is somehow black and white. And I think that this black and white thinking very often just leads to a single answer. Very often the answers are manifold. So what we also try to develop is some kind of use case identification framework where you can ask yourself some questions first. Am I working in a network? Who is the intermediary in this network? Am I self the intermediary in this network? Big danger, yeah? Probably I can be replaced, or I can just optimize my network. What kind of data do I need to store? What kind of things can I automate? Similar to the example I just shown previously. And then you can map that somehow to a use case canvas by identifying what are the particular properties. What is the network I'm working in? What is the data I want to store there? What are the smart contracts I probably can apply? In particular, what is the automation potential that I see? And just by doing that, at the end, you will not get a single answer. Your use case is 75% blockchain ready or blockchain suitable. But just by doing that, and in German we say, well, the way is the goal. Yeah? Der Weg ist das Ziel. Yeah? But just by doing that, you become aware on how you really can deal with that and whether you should really go the next step by developing a proof of concept. And then you come to the next step. How do I integrate sensors and oracles? I just mentioned at the beginning that we do a bet. If Germany wins, I said 2.0, you get €5. Who is telling the blockchain that Germany won 2.0? It's external database, external website, and the blockchain will just execute what you tell it. Yeah? It's garbage in, garbage out. Yeah? So not everything that you put in a blockchain is the truth. What you read from a blockchain, it just has not been changed since it has been written. But you always have to take care who wrote it into the blockchain. Yeah? So what we need is sensor and oracle integration. So the oracles are the external services that are being asked by the blockchain for certain information. So it's the website of the FIFA, or maybe even better, the website of Kicker, if you don't trust FIFA, yeah, who tells you the result of the last game. Then we have identity management. Who put in some particular data? In this case of our certificates, you need identity management to track, was it the Technical University of Aachen who issued that certificate? Or was it just the student himself who wrote the certificate in the blockchain? And then you prove the certificate, and then it tells you, well, this certificate has been written into our blockchain in January 2017 by the Technical University of Aachen and not by University of Aachen, which just sounds similar. Yeah? So we need identity management, and for that, there are also solutions around, like sovereign or other approaches. Sometimes it's also already part of the blockchain infrastructure itself, like in Hyperledger Fabric, where we do the identity management of the items that are represented in the blockchain. The next thing is the blockchain is not a database. You are not storing big data in the blockchain, just based on the principle that it's being replicated everywhere with all the different nodes. What you store is just a fingerprint of your data in the blockchain to ensure the consistency of the data itself. And this fingerprint, the so-called hash code of the data, this is something that you represent in the blockchain. And then you have to ask yourself, where do I put the other data? Do I put it just in a relational database, in the interplanetary file system, which sounds very cool? That's where we store our data in, or other kinds of media. All that's possible. So that's probably also sometimes the myth that you store all the data in the blockchain. It's not a database, it's a ledger, it's a registry. If your data really is big, like a movie, and you want to ensure your copyright on that particular movie, you wouldn't store 5 gigabyte of a DVD in this blockchain. What you would do is you hash that, you store the fingerprint in the blockchain, and that allows you later on to prove that that is actually your movie. And then the question, who am I and how many? It's a nice question that a German philosopher was asking, wer bin ich und wie viele? What does it mean? Do we have just the single blockchain? I think we won't. We will have many blockchains, even within your organization, and for different applications. And you will have data, and you can register the data, as I just mentioned, in the blockchain for your private asset management. And you even can register your private blockchain then, or your permission blockchain, in the public blockchains. Because people may come and say, well, I know it's a consortia blockchain. In general, I trust you. But maybe, just in case, you tampered around with your data. And they could just tell them, look, I just took a fingerprint of my blockchain 1 week ago, and here you see we registered in the public blockchain. Let's take the fingerprint again and compare it. And you see our blockchain is still in the original state. We didn't change it before we showed our supply chain data or whatever to you. So you see manifold ways how to apply the whole blockchain principle. And that comes then to the next question. If we have all these different blockchains, how do they talk to each other? So we need interoperability, we need standards, and even the ICO and other kind of standardization consortia took up this topic, and they also now have launched working groups that deal with interoperability of blockchain, because that is what we needed also in the next future. And also, how do I govern a blockchain within a consortia? That's also a very interesting question. So, if you want to see particular blockchain up and running, in particular for education, giving the use case that you are a certificate provider, like an academy, you provide certificates for your products, you find a solution there in our booth. And to sum up, I hope I could provide you some insights on why blockchain is relevant, what are the basic properties of a blockchain. It's the irreversibility, the difficult English term, comprehensibility, automation, and the whole decentralized approach. And if you want to start now, what needs to be done? You should analyze your processes and your business model. Is this actually affected by blockchain? Can my business model be attacked by the blockchain, or can I just extend my business model? Don't take it always so negative. Maybe I can do something better using that technology. How can I establish a network? Identify some relevant use cases, do a proof of concept. This can be done in a very agile way. We have some experiences with that, 1 month, 2 months, and you have your blockchain up and running. So the development times even decrease because the technology becomes more and more mature. Do some kind of market observation, see what's going on. What are my competitors doing? What is the network doing I'm involved in? We have a lot of networked organizations. How are they dealing? What's going on there? Do I see already some startups coming up with some ideas that are similar to my business model, and organize yourself in particular networks? And if you come up with some of these things that you say, well, that could be relevant for me, just try it out, together with a company, together with the university, together with Fraunhofer, and then you really, in the end, can answer the question, is blockchain relevant for me, in a very good manner. And even if blockchain is not relevant for you, don't worry. I mean, the best thing is that you digitize it all. And very often I say, well, if you have found a process that you think it can be put into a digital environment, and even if it's not blockchain relevant in the end, just do it. Whether you do it with blockchain or not, it doesn't care, but go this way. If you can do it with a blockchain, fine. If not, also fine. But I think we now have a new technology that can help and provide some kind of very new, interesting solutions. And in the future, we will see a lot of them. And very often I compare the blockchain that we see now with HTML in its first version. Think about the first web pages and what you could do with that while you were editing that. And think about the way it went. Services, automation, Internet of Things. And imagine if the still very early blockchain technology, although we got Bitcoins almost 10 years ago, the big things are just coming up over the last 2 years. If this goes the same way, in the future we'll see a same boost of this technology as we saw it for the internet. And with this, I would like to thank you for your attention. I hope I've interested you into the topic. I wish you all the best now for the rest of the presentations all over the day, or all the big blockchain exhibits that you see over here. Thanks a lot.
Thank you so much for joining us. Thanks for inspiring us. Actually, we have a few minutes if you're ready to answer some questions.
Welcome.
Are there any questions from the audience? We have one. Okay, we have a mic coming towards you, second row. Thank you. And then if you have questions, just raise your hands. I'll look out for your hand, and you can keep it up. And you may repeat the question for us. Thank you.
When do you think the real disruption will be felt by the consumers or business?
So you mean when the real disruption will take place? Or?
Yeah, because now we don't feel it, right?
Yeah, you don't feel it yet, yeah. Well, I've often asked this question, and I think that we will see in the next 2 years. Yeah, I also asked the audience at another conference, and what do you think when the big disruption will come up? This year, next year, in 2 or 3 years? I think what we will see in this year already, and if you go to some business companies here, they show you a lot of not just proof of concepts, but really running systems there. I think we will see it first in the optimization of back office processes. What a lot of people do, or companies do, they optimize their back office processes by just putting some tracking data or production data in the blockchain, and they see how we can optimize that. What we will then see in the next wave is the idea that we put some kind of decentralized autonomous organizations in there. For that, I think we still need a better understanding of the organizational matters and the technology with this. I would say in the next 1 or 2 years, we will see some kind of disruption going on there. Or just changes. I wouldn't call it always disruption. Yeah, maybe just changes that take place, and maybe several of them will just be evolutionary. And then we will much better understand what's going on there.
Thank you. Thanks. Any more questions? Yeah, right over here. Did you see somebody else? Yeah. Maybe you saw it first. We'll get you too.
Okay.
Ja, es gibt ja viele Kryptowährungen, die sich immer durch Forks aufteilen. Das sind also diese Spaltungen der Blockchain. Ja. Ich meine, das ist ja quasi so auch eine Wertaufteilung, eine Vernichtung. Ich meine, diese Blockchains, es gibt so, keine Ahnung, ein paar 10.000 Kryptowährungen, und dann der bekannteste Fork war dann von Bitcoin zu Bitcoin Cash. Ja, da werden halt so Veränderungen vorgenommen von den Transaktionen, die pro Minute durchgeführt werden können. Ja. Aber Sie sehen ja eher die Blockchain eher so als Datenspeicher, nicht so als Wertspeicher.
Yeah, right. So the question was, sometimes blockchains are being forked, which means that you just say, well, up to now we were running version 1.0, but we detected some new opportunities, and now we have version 1.5, and we still run the old one and the new one. It happened to Ethereum in a case where they detected some problems with a particular smart contract there, and also other people do it in order to split up into different cryptocurrencies. Yes, that happens. And that's really a deal when you talk about cryptocurrencies. And there you really have to think about what does it really make to the financial status and the trust in these cryptocurrencies and things like that. That's one thing. My main motivation working on blockchain is not just the cryptocurrencies. It's more really on using it in business processes, in representing data there, in representing value there that is not just cryptocurrencies. And I think obviously also there we will have forks. And maybe even just in a closed consortia, you may say, well, we were running this blockchain now for 2 years, and now we just stop it, and we just save the data somewhere else, and we just launch a new one because we got new functionalities there. And I think that's just possible, and we just should do it. For cryptocurrencies, it's different, because I wouldn't like that the Bundesbank just tells me, well, your euros are just useless. Yeah, we just brought up something new. Yeah, so we really have to differentiate here between the whole cryptocurrency business and the rest. And for the rest, the whole dealing and the governance is much easier than with the cryptocurrencies.
Thank you. Thanks, sir. We have, I think, this gentleman first, and then we have a bunch more questions. It might be that we don't have enough time for all questions, but then you'll be available afterwards, right?
Yeah.
Okay. We'll do a couple more. Thank you.
Thank you. I would like to have your views regarding the main challenges when adopting blockchain, considering that now the business are not only national or regional, but global, and considering there are different partners as well.
Yeah, he was talking about the main challenges in blockchain in general, I think. The main challenges currently is that you have to convince people that first thing, it's not just Bitcoin, it's not cryptocurrency, it's something else. The next challenge is that you really have to analyze your business processes for the blockchain relevance, and then it's also an organizational change that you have to live. And what we see in some projects actually is that we're talking about a blockchain that we are running, for example, within 2 or 3 partners. And then we say, well, we are now extending that. And we think about potential other partners in which we run this particular blockchain. And then we think about some names. And then some of the partners say, oh, no, that's our competitors. We can't join the blockchain with our competitors. Yeah, we want to own that, and we want to license it to them. And then you have to say, well, that's not the original idea that we just license a blockchain to someone else. We may license some smart contracts or so. We may ask for running the blockchain or so. But we have to think in a new network. We have to apply a network thinking where a lot of even competitors work together on this particular blockchain to exchange data to run business processes there. So I think we have also a change in the mindset, in the organizational thinking, as well also somehow in the technology. As I said, the technology is up and running, and you can do a lot of it, but some people still say, well, it's in its early stages of maturity. Yeah, sometimes also the things that we are running, sometimes they crash completely and you don't know why, and things like that. But that will overcome. Even the first web servers, they crashed without any reason.
Thank you.
Yeah.
We'll do one quick question. Thank you.
No.
Oh.
Yeah, no. One quick question. So what do you think of the role of the hidden champions? If I'm like a mid-sized company in Germany and I want to have a blockchain project, can I do it with my own IT and my own staff? Or would it be more like a service provider who come into the market for delivering the IT platform for to host a blockchain? Yeah,
whatever you like. I think that's a very interesting thing, because when you currently look at the companies who are doing blockchain, it's the big ones. They have the money, they have the IT departments to do it, and the small, medium enterprises, in the end, they may just been overruled that, for example, a big car manufacturer tells you, well, you're the hidden champion producing some kind of nice wheels, and now we put all our whole process on blockchain, and please revolutionize your IT. Yeah, so that's also something that can happen. Therefore, I think that also the small, medium enterprises should have a look at that. How can you do it? I think what you can do is get in touch with some partners that do first the job together with you, who are experienced in blockchain, who have a good view on the blockchain possibilities, discuss with them your business, exchange your ideas, and then identify the blockchain relevance for your business itself. And you can do that either with business partners or, obviously, even better with research partners who are also doing that. Then the next thing is really to play around with that. And there I would say do it together. Yeah, don't give all this experience away. Do it together with solution providers that are more and more popping up. So do it in an agile way together with a company, with Fraunhofer, with the university, also to get your own experience. And I think if you have a clever developer also in your IT department, who is enthusiastic about it, he also can do it. Writing smart contracts is not magic. Yeah? Okay. What is more magic is in the end really to set up the infrastructure, to get it up and running, that you have to do it in a network, but there we run into organizational issues also.
Yeah, because we are a service provider for blockchain, like Ethereum blockchain as a service, and I would agree to you that the competency of developing the use case, that should be into the companies, and all the infrastructure could be an outsourcing way.
That's somewhere else. Yeah, you don't need to run your mining node or your node or whatever you choose in your own organization. You really can put this up into a computing center. Somehow I would say don't put all the nodes of your network in one service provider, because then you somehow overcome the whole idea of the blockchain. Yeah, I mean, we sort of distributed network, choose 2 or 3, and then you're fine. Okay. You can even do it in one, but maybe then a lot of blockchain enthusiasts will say, no, that's not right.
I know this discussion. I have it as well.
Yeah.
Thank you.
Okay, you're welcome.
Thank you for your questions. Wolfgang, thank you so much for inspiring us. Thanks for coming and introducing the topic.